How can astronomers determine distances in the far reaches of the universe? A small galaxy close in looks similar to a large galaxy farther out. This is a real challenge that researchers have found several solutions for. One method uses something called a standard candle. A standard candle is a type of object or event that emits a specific known amount of light, allowing scientists to find its distance with a straightforward formula. This works because light sources appeared predictably dimmer the farther they are from an observer. Since astronomers know how much light a standard candle gives off, they can determine its distance by measuring how dim it appears from Earth. Since only very bright objects or events are visible in the far reaches of the universe, the options for standard candles are limited. Some of the best and most reliable are exploding stars, called supernovae. There are a few different kinds of supernovae, but the best for standard candles are type 1a. These supernovae involve a white dwarf, the leftover core of a dead star, and one other star in a binary system. Some of the time, it may be a white dwarf and a larger host star. Scientists think the white dwarf steadily accumulates material shed by the host star, gaining mass in the process. When it reaches a specific tipping point, the white dwarf has gained enough mass to trigger a runaway reaction at its core, and it explodes spectacularly, sending out an expanding sphere of superhot material that glows from the energy of the explosion. In other cases, scientists think two white dwarf stars may form the binary. Either the stars finally merging together triggers the supernova, or it happens as they spiral in closer and closer, while the more massive of the two pulls material off its companion in the final few minutes. Before they merge, it reaches the same mass tipping point and goes supernova, always releasing a similar amount of energy. Because white dwarf explosions are all so similar, the energy and light output of type 1a supernovae are easy to standardize. Type 1a supernovae are rare in any one galaxy, occurring only once every 500 years or so in the Milky Way. But because there are so many galaxies, astronomers using current telescopes observe type 1a supernovae about 100 times a year. By comparing the observed brightness with the intrinsic brightness, astronomers can determine their distances within 6%. The Nancy Grace Roman Space Telescope, set to launch in the mid-2020s, will observe large patches of sky repeatedly, increasing the opportunities to spot these supernovae. Scientists predict Roman will see as many supernovae in 1 month as they've found in the last 20 years. Finding more of them will help astronomers refine the accuracy of this method, contribute to an improved three-dimensional map of the universe, and better understand how the universe has expanded and evolved throughout cosmic history.